Hi, welcome back, everyone. Thank you for joining us. I'm Nick Bray from MBA. We're an architecture studio based in Victoria and here in Vancouver on these beautiful unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh nations. We're hosting these seminars to fill a gap in education for architects and share learning about relevant topics that we currently are impacted by, and likely you are too. Our next seminar will be on November 18th. It will be about working with Indigenous communities on architectural projects. Brett McIntyre from our office has organised this event with speakers Corey Douglas, who is a Coast Salish cultural consultant, an artist, and the owner of Modern Formline, and also Eric Hunter, who's the director of the construction firm Sue Projects. Yeah, I'm really excited about that one because it may be more practical than other seminars you may have experienced relating to this important subject. We're going to take a break then in December for the festivities, and then we'll be back on January 27th for seminar 10, which will be about designing with mass timber, focused on innovation, performance, and workflow. And that's going to be presented by Eri Uthoff and Danny Greenberg from Kalastikoff Mass Timber, who have a large modular prefabrication facility in the West Kootenay region of BC. So yeah, excited about that seminar too. And we're also lining up further seminars next year. At least one of those will be with Celerity Engineering. So please, keep an eye on our Eventbrite and our LinkedIn to see when those seminars will happen. And if you have any suggestions for future topics relating to challenges that you're facing in your work, then please feel free to share them in the chat box or send me an email. Also, please use the chat box to ask any questions during this seminar. We'll do our best to answer them at the end. A link to the online AIBC accreditation form will be provided halfway through and again at the end. So please have your AIBC number ready if you have one. And thanks for everyone for filling out the poll. And we're pretty consistent, about over 90% architects in this seminar. So thank you everyone for joining us. So I'm really excited about this session here, especially after our dry run with Xun last week. The subject of AI in architecture is fascinating and thrilling. And if you're like me, it's also terrifying. But Xun certainly took out some of the fear for me in that session. So just to introduce Xun Liu is an assistant professor at UBC School of Architecture and Landscape Architecture. Her work focuses on applying artificial intelligence to generative design and developing novel data-driven workflows for practice. Through her consultancy, she collaborates with design firms to integrate and customize AI tools for real-world architectural and landscape projects. She previously worked with STOS Landscape Urbanism and with the New York City Department of City Planning. So thank you very much, Xun, for taking your time to join us today. Over to you.
Yeah, thank you. Thank you for the introduction. Good day, I'm Xun Liu, and I wanted to say thank you for joining this virtual presentation today. It's a pleasure to have this opportunity to speak with all of you about the topic on AI. So the title of the talk is Beyond Default, Architectural Specificity in Generative AI. And I want to say my central assertion today is AI is not a threat to the designer, but it's an amplification of design agency. We must move beyond the field of automation and embrace the reality that AI lowers the technical barriers associated with complex digital tools. It makes the sophisticated workflows more accessible and will ultimately strengthen the designer's role and free us to focus on creative problem solving. So a little bit more about my background and why leading my interest to AI. So I was trained as in both architecture and landscape architecture. and well, just joined UBC SALA's, but I'm teaching in both programs. So I recently completed my PhD in at the University of Virginia, where I focus on the application of AI in the built environment, and both in a technical way and theoretical way. And before academia, I practiced for a few years, but mostly working on the support of the internal workflows and collaborations, developing digital tools in collaboration with public and private agencies. So I think I approach this topic from the perspective of generation for whom the computational method are a natural extension of design thinking. And also as an educator, I'm preparing the next generation of designers for whom I think the digital tools are even more intuitive for them. So this blend of practical research and pedagogical experience shape my assertion that AI is a critical tool for advancing creative workflows in our profession. So I will start from a quote from Andrew Ng, a leader in the AI field. He said, AI, like electricity, is general purpose technology. And this is the perfect analogy. Just like electricity transformed every industry, AI has the potential to reshape how we work across all fields, including architecture. But the key is electricity only become truly useful when it was adapted to specific needs. Powering nights, motor, computer. Raw electricity is just a force. The same is true for AI. So to unlock its value in architecture, we need to move beyond the generic tool and customize AI to fit our discipline. A generic AI doesn't understand what program, what structure, what is BC building code. So you need to be taught. So we begin with visual tools. This is the most mature and most immediately recognizable area of AI, of course. And it serves as an entry point for most firms and the primary focus of media integration also in my own courses over the past 3 years. And the example I will show were largely developed by my students from University of Virginia to US University of Southern California and currently in UBC. So I have noted the specific tools and the years they were created. The goal is just to emphasize the rapid evolution of this technology. What was cutting edge 1 year ago is now actually maybe a standard feature in Photoshop that everyone can use. And many of us have tried tools like ChatGPT or image video generation like Midjourney. They're general purpose AI tools trained on massive public data set. They are powerful for instant aesthetic synthesis, like text to image generation. And within the design studio environment, students utilize these tools as a mean of rapid generation, two-dimensional visual assets that can be incorporated into conceptual collages and early stage design explorations. They also serve as a rapid storytelling tool, allowing for quick envision of future that do not yet exist, such as this student's project at UVA. They explored the impact of sea level rise on local community. And designers can easily translate a napkin sketch or a simple Rhino massing model into a quick conceptual rendering. You can provide the structure of the image sketch. They can rapidly use text prompts to experiment with different scale, atmosphere, material palettes, testing iterations of facade in brick, timber, glass in seconds. While respecting the massing, the structure from the sketch. And these tools can also automate segments of the traditional workflows, like this, for example, the translating the line work. from CAD or other 3D modeling tools into a colored plan. Or screenshots from 3D modeling from SketchUp or Rhino into developed renderings. And this is example my students explored 2 years ago, inputting one base render alongside a separate material ID color block image, which function like a graphic mask to precisely guide and control the resulting material selection in the final image. This is a workflow artists already understand. It's conceptually similar to the render output of clown parts from Ray to use in Photoshop. So the AI just consume this path and apply material more intelligently. And this is just a more playful example that translating physical modeling process in real time. Here, just playing with plates. But imagine pointing a camera at quick foam core or basswood massing model on your desk, and this process combine the physical prompt input with real-time physical input with real-time text prompt to generate a visual result. Though the resulting visual are less accurate, the process is more engaging. So there's a trade-off here, but creating a tighter loop between the physical and digital making. So it brings back the tactility of early design exploration that is often lost on the screen. And beyond initial ideation, the image-to-image generation is useful for high-fidelity renderings and post-processing. And there are already many commercial tools can be used for this specific task. And this is an example, or this example was created by a friend who works at a field operation landscape firm, but the technique is identical for architectural visualization, that they use AI to refine a screenshot directly exported from SketchUp or Lumine. And we can think of AI as a photo filter, just a more intelligent one. And this intelligent filter lets you quickly adjust materiality, seasonality, atmosphere without hours of masking in Photoshop. And you can directly say adding more diverse entourage, adding more people, change the material from mass timber to glass, and it will understand the context of the image. And you can also do context-aware image editing, which allows you to use the text to instruct changes. This is an example my student created 2 years ago using the function called generative fill in Photoshop. So it's style and scale aware of the context, but it often fails multiple times before producing a good result. Especially with complex architectural perspectives or junctions. It struggled with the clean lines. However, this technology is advancing rapidly. So a few weeks ago, Photoshop released a significant advanced version, Photoshop Beta, which integrates the most powerful AI image generation model called Nano Banana, or another name is Google Gemini 2.5 Flash. And the image generation model is so advanced and now it's integrated in Photoshop. And well, actually beyond this, these are some demos I find show the powerful that you can directly circle out the instructions in Photoshop, and it will follow the commands. And of course, beyond using it directly in Photoshop, which I would say is kind of a cut-off version for from the full version. I also recommended it directly exploring this model directly in Google AI Studio.
AI model by Google.
Oh, I should close the sound. So it can translate plan to perspectives, sketches to renderings, and much more. And what's new is it improves understanding of architecture representation. And you can upload a floor plan and ask for a eye-level interior perspective of a main living room, and it has a much better chance of understand the spatial relationship and generate a possible view. And this model offers accessible entry point, a minimum learning curve. Everyone can start using it within, like, I would say 10 minutes. And it provides a very controllable multi-angle outputs, which is excellent for generating, like, matching elevations, matching the different angles of perspective. And the result is also high fidelity. And the way you use it is through the iterative conversational chatting. Here are some more examples, and currently there's a lot of demo videos on YouTube you can find, and how designers can use it. For this example is you can upload a plan drawing, and it will render it in a realistic way. But you can also just to say, I want to lower the perspective. I want to lower the view a little bit lower. I want to create a human perspective instead of eye-level perspective. So it is aware that though it's not, like I was saying, it's not super 100% accurate, but you can get a start from there. However, for firms requiring more controllable, complete control and open source flexibility, and integration into the proprietary workflows, I think, it's jumping. So at the present time, the tool called Stable Diffusion may still be the appropriate choice. It's better suited for developing secure firm-specific visual model trained on your own firm's past project to replicate a specific design, language, or rendering style. And the default tool are already super powerful, but their limitation is a lack of discipline intelligence. They understand visual style, but not program, structure, building code, or spatial logic. So they can make a pretty picture of a building, but they cannot design one. They don't know why a core is placed in a certain location, and a hallway has minimum width. So therefore, for AI to move beyond rendering filter and become a true design partner, one can assist with layout, massing, even systems integration, customization. Here is the key. So how do we get there? How do we customize? So, and from a technical view, there are three things we can do. So the first is fine-tune AI with selected data. And the second is use non-visual data as design media. And the third is to design the data flow that integrate AI into our creative process. And I will start from the first thing, so from fine-tuning. So AI is fundamentally data-driven. Unlike CAD or BIM, which follows fixed rules, AI learns pattern from the data we provide. So fine-tuning means take a pre-trained generic AI model and adopt it to specific task using a curated specialist data set. It's like taking a general practitioner and training them to be a neurosurgeon. So for example, in ChatGPT, you can create your own customized GPT by uploading selected documents and specific instruction. These are called GPTs. This is an example. I think it's available to everyone. It's called BC Building Code Explainer. It's expert on the BCBC code and National Building Code of Canada. So it's invaluable that as assistant trained specifically on the regulation documents that govern our practice. So imagine especially I would say it's useful for junior architects. So as a junior architect, you can ask, what is the travel distance limitation for like the F2 occupancy on the third floor of so asking about the regulation, you get an instance and cited answer with the correct code section. So this is a massive time saver for preliminary design and code review. And of course, you can easily build your own customized GPT by uploading your own document and your customized instructions. And it's the same for image generation. Many image generation tools allows customization. So in Midjourney, the more artistic image generation tool, there's a feature called mood board, and you can upload your own set of image library to guide the style. And there are also the tool I mentioned, Stable Diffusion, open source one. There are also many fine-tuned model in the open source community. So you can download the other people's trained fine-tuned model, and also some design firms they trained their own model on their own project image to ensure style consistency and avoid copyright concern. And this is example, a group of designers at SWA. They actually fine-tuned the model to mimic their one of their design principles, hand sketching style. Though I would say ethically interesting, this is what many large architecture firms have begun doing, establishing their own customized AI model to maintain a consistent brand identity in their visualization. So this is about brand control in a world of generic imagery. But the potential of this method goes beyond applying just a visual style. It's about teaching AI to understand domain-specific knowledge and spatial grammar. This is actually an experimental project by my students. The project is called Text to Garden. The goal was to teach AI to generate color-coded plan layout. And the team, they connected the garden plans of all the existing traditional Chinese garden, and they manually color-coded different elements like hardscape, planting, water, and provide paired text descriptions of the spatial relationship, and feeding AI with both the color block image and text descriptions. And in this way, the resulting customized AI could then generate similar garden schemes based on text descriptions. And well, imagine this, the same logic applies to architectural plans, and train AI on a data set of 1,000 floor plan, and it would just learn not beyond the style. It would understand the deep, non-obvious pattern about the adjacency of different programs. And this is actually many researchers in academia. They have research about this area for many years. And in another experimental student-led project called Text to Poche, my student trained AI to understand spatial relationship in architectural sectional drawing. And they extracted sectional figure ground drawings, the poche, from selected building and labeled each building with the building typology, the name of the building, and the designer's name. And the resulting AI could then generate multiple sections from just text descriptions, and which were subsequently used to construct 3D model. So this is a powerful method for typological study and early conceptual mapping. And beyond teaching AI new concepts, we can also fine-tune using local and contextual data. So this is my research project called Plants AI, which is supported and collaborated with I would say the biggest landscape firm in the States. In this project, we aim to generate a plant distribution pattern that mimic the natural system based on local site condition. So the idea is to train an AI model using local planting distribution data to simulate how plants will naturally grow on a site without intentionally planting design, simply follow the natural pattern. This diagram is a little bit more technical, but the idea is here we kind of we connected the data, the site data, synthesize in a way that AI can understand different aspects of the topography, soil, and climate data, and we use that as an input, and the plant community pattern is what the AI can output. Well, because I'm not an engineer, so the goal is not to build like a super accurate model, but the idea is after we create a reasonable AI model or a relatively accurate AI model, we tried to integrate this AI prediction into 3D modeling. So it will allow designers to adjust like the landforms, the ground material directly in 3D modeling tool and instantly see the planting pattern result prediction. And we applied into a huge park design project. And the designers has designed the topography and the ground material. And we used AI for the first round of generating how the plants will grow naturally that echo surrounding ecology. But this is not design and is still experimental, limited by the data, the oversimplify of the ecology behind it, the availability and resolution of data. But the idea is to show how fine-tuning with the right data support not domain-specific application, but also support it can learn from the contextual, from the local data. This is where domain-specific AI becomes powerful, and it will be used case-specific, not replacing our expertise, but encoded into the tools we use. And a second aspect is use non-visual data as design media. How we represent design problem through appropriate data type, and how we interpret the result into meaningful forms. And the way we structure and encode information has a big impact on how AI can understand and what it can generate. So in architecture, representation goes far beyond just visual. Data isn't limited to text and image. It can include spatial, semantic, relational formats. For example, consider this 3D mesh model. Just like image generation, there are already many off-the-shelf commercial and open-sourced mesh generation tools. You can use text and image prompts to easily generate 3D meshes. And we can use this to quickly generate 3D assets like sculpture, furnitures, no need for 3D scanner or a complex photogrammetry technology. You can easily translate physical model into the digital world, and we can simply take photo of a handmade foam massing model and directly digitize it for further work in digital tool. And design can also encode it as a 3D point cloud or a voxel model. This is a project done by Imuna, a researcher in Singapore. So voxel model of the past project from Zaha data architects were used to fine-tune AI, enable the model to generate new forms in a similar spatial language. And this is a clear example of encoding a firm's specific design DNA in its formal spatial preference into a generative tool. Well, in practice, there are more tools that can directly assist the design workflows. So the design here is represented as plan layout, spatial relationship. In this example, my students have tested a lot of plan layout generation tools, and we find this tool called Finch 3D is the most powerful one. So Finch 3D is an AI tool that used in architecture that models design as room program and the links between them. It focuses not on the final form, but the functional logic of the space. So it will optimize adjacency, circulation, and on programmatic requirements you provide, and you can directly integrate it into 3D modeling process and export BIM model from that. And however, there are some limitations. Is currently it only works for the residential plan layout. So beyond residential development is a tool that doesn't have the integrated other programs. But I want to say that the most promising method is actually not asking AI to directly generate a design form, but rather teaching AI to use the design tools. So instead of generating form, AI can learn how to use tools. This involving technology is called Model Context Protocol, the short term MCP. So it's a standard bridge linking large language model to different digital tools. The MCP ecosystem is expanding rapidly. This concept was invented or is getting popular at actually starting from earlier this year. So it has the power. It has the power to connect to all the digital tools like PowerPoint, web browser, schedule, Google Calendars. So it's the same. It can also link to 3D modeling softwares, GIS tools, and CAD tools. Not all tools designers use are practically ready yet, I would say, because this technology is very new, but the technology is evolving very fast. So earlier this year, MCP for 3D modeling tool, the Blender, was developed, I think in February or in March. So it allows the large language model to create 3D scenes. You can adjust the camera angles, control lighting, and directly create animations by just feeding text prompts. So the text prompts will translate into the instructions into the 3D modeling tools. And later, MCP for Revit emerged, and you can use it for auto dimensioning, for automatically calculation and code compliance checking. But these demos looks fancy. However, I would say many of the tools are still error prone and are not ready in practice now. But I think this is an area that will change rapidly. Maybe it will be ready in a few months. And Autodesk, they also announced their own MCP tools is coming soon. I'm not sure when it will be available. It will change significantly how it will increase our workflows significantly. And there are also some open sourced MCP tools, community-led open source MCP. For example, this one, the Rhino MCP links the language model for 3D modeling in Rhino. Though still in its early stage, it enables some automated 3D modeling, and it will significantly change how we interact with, how we learn different design softwares, and also for me as an educator, how we are going to teach this software. And this is a work in process project. My research was focusing on this summer. This summer, I created this MCP tool for linking language model to parametric modeling. And this demo was developed by a group of landscape students. So they helped me to develop this specific landscape modeling toolset that enable language instruction translating into 3D modeling logic. And well, I want to say this again. So this is still early explorations. We're finding the balance between, because we need to find the balance between creativity and control, between specificity and flexibility in this modeling process. But as things evolving rapidly, more software is embedding AI using the large language model as interfaces. How should we teach? How should we learn the digital tool? How should we interact with this complex digital platforms? And how should we control? These are are very important questions worth thinking about. We need to think about now. Well, the last part I want to say is designing the data flow is very critical. So the default use of AI is often one-step process. You type a prompt, get output. But we all know, like if you just type, I want a building for this site, it won't produce a meaningful design. So to be useful in our workflow, AI needs to be part of iterative workflow, where human review, designers will review, adjust, and reflect, and AI can respond and improve across steps. So here is a diagram of showing that we can see the traditional design workflow as a flow of inspiration and creation, followed by reflection and recreation. So a back and forth between external design problem and internal knowledge, intuition, and experience. And using AI-assisted, augmented, or partially automated workflow, we can open up new possibilities. But human designers should still lead the process, especially at the key decision-making moment, ensuring that design remain intentional and grounded. So based on this idea, I'm currently teaching an architectural studio this semester in UBC. So the technical barrier is much lower than we thought, especially with current AI tools. And my students this semester, they are they are architecture students with design background. They have no coding experience, explored AI tools in their, and they developed this in their first assignment within a month. They built customized workflow apps entirely without coding. So the first app, I will show two examples. So the first app created by a student, my student Carl Lam. So this app is called Blueprint AI. And his workflow integrate visual generation, site analysis. So he kind of split the visual design workflow into nine different steps. Or start from the conceptual to site analysis to image refinement. And so this app lets you start with text prompt with uploaded sketch. You can specify the building program, the style, specify the site address, the project type. You want renovation or new construction, and you can upload a site image. And the AI will return a basic site analysis, including the sun, the context, the wind, and conditions based on the location. And it generates some initial sketches for you, because in this case, he wanted to renovate the existing building. So it will generate some initial sketches, which you can select, or you can regenerate one if you are not satisfied with the result. And the chosen sketch becomes an initial perspective rendering. And you can also choose the one if you are satisfied with the result. And you can continue starting from this initial rendering. You can then adjust like the facade material, adjust the percentage of openings, and rendering atmosphere, what kind of style you want. So after you set the basic parameters, it will give you like the different material palette. You can choose, for example, stone panel as a facade, and choose the nighttime lighting as the rendering style. And AI, well, this app is developed in Nano Banana, Google Gemini 2.5 Flash model. So because the Nano Banana is so powerful of the consistency of different angle, so AI will then provide multiple views, interior, area views, and it will also give you some material board, and can directly generate like a short video clips. And this is a full demo because the earlier example I showed is like a screenshot. This is more real-time running. I speeded the video a little bit, but this is a demo how the app work. So you can upload a sketch, it will give you different options. You can select the one you feel comfortable and move to the next step that put the sketch directly put into the site. And you can choose and refine the rendering, adjust the material to mix with wood and stone and apply the material, dark color tone. And also adjust the openings and change, set a different rendering atmosphere. And it will produce the perspective from different angles, but not 3D model, just like a different visual styles. And regenerating the material palette and develop a video clip from that. Okay. And the output can be, there are some emergent tools by using this tool. I think this could, I forgot to put it here, but this tool is called Marble. So basically what Marble is a new tool that we can upload the multiple images, and it will export it as like a point cloud 3D exploration. But it won't generate a 3D model. It's just like a provide like a walkthrough inside the building or outside the building, outside of the space. And this is another app developed by another student. So he built a different app focused on the building material design. So it's quantify the material used in a rendering and estimate both cost and embedded and embodied carbon emissions. So you can start with a sketch, then you enter the project area, FSR, height, number of floors, and choose a style and a material palette. And after selecting a preferred rendering, the AI will estimate the amount of different material for the facade only. So the different facade, the quantity of different facade will be estimated, and the estimation may not be perfect accurately, but my student Amo, he included the option. So you can, as a designer, you can manually adjust the quantity if you feel the AI estimate result is not accurate. So he also built a cost calculation based on Vancouver market price. But definitely that is a number you can also manually adjust. And the AI it will also generate embodied carbon report. And the student actually, I'm not like an expert in this area, but the student is expert in this embodied carbon calculation area. He researched extensively in his undergrad thesis, but he's able to directly link that expertise into this workflow. So you can continue refining the design using language prompts. So you can adjust, like you can set a goal. So the budget is we don't have enough budget. What are the alternative visual you are going to build? So it is, though because this is definitely is not, though we can see the potential in practice, but this is a student work that they build in like, this example is actually built a little bit more than 1 week. But it is remarkable to think about how quickly they build these customized workflows. Just demonstrate that like designing AI integrated process is now accessible without any coding experience. And it allows designers to focus on embedded their domain knowledge directly into tools. So as a summary, we as designers should take the lead in these 3 aspects. So fine-tuning with selected data, curated data, and secondly to use the non-visual data set as as design media. And third is to designing human AI workflows, data flows. And our role are evolving. We are no longer just a form maker. We are also data curator, evaluator, and workflow designer. And going beyond default isn't just a technical step, it's a shift in how we think about tools, authorship, and design in architecture. And I want to finish with some takeaways. So some takeaways on the technical aspect. I would recommend starting with Nano Banana is the Google Gemini 2.5 Flash model, which is currently is free to use and is a great entry point if you haven't played with AI before. It can replace most of the commercial AI rendering tools, I would say. It's very consistent, easy to use. And another thing is to keep an eye on the MCP tools, which are coming soon to many software platforms, and will expand how we connect AI to our design environment. It will make our work much more efficient. And most importantly, I think as architects, as designers, to stay informed by following the demos, AI news, and emerging development in this field, because everything is changing rapidly. And takeaways on the conceptual level, I would say like remember that AI is general purpose. It requires specific adaptation to be truly useful in our work. So I would encourage you to embrace AI's potential, as it can have significant impact in design. And I totally understand the panic. I also are filled with how fast this technology moves. But our field is, I would say, our field is because we are in creative industry. Our field is less standard than many others, like the more engineered domain. So I actually worried less about replacement. Instead, many unique aspects that benefit from AI assistant. So I would say stay open-minded when testing and exploring new tools, but still remain cautious and critical when adopting them into practice. And well, lastly, because I'm in academia, I'm interested in collaborative project with practitioners to explore AI-assisted workflow. And currently I'm particularly focused on three areas. I'm interested. I have some research fundings on the public engagement on local regulation, integrating of local regulation in Vancouver, and how AI would help us to read the local regulations. And the third aspect is on the digital modeling, digital 3D modeling workflows. So if you are interested in collaborating, feel free to reach out my email. You can also find my contact info on UBC faculty page. Okay, thank you. I'm happy to take any questions.
Thank you. Thank you so much, Shun. This has been enlightening. I mean, the apps that your students are building in 1 week, I don't even understand how that's possible. It's astonishing. Thank you so much. Before we get into the questions, I'd just like to take this opportunity firstly to thank Shannon and Ori in our office for helping organize and facilitate this seminar. This will be on YouTube along with all the other seminar videos that we've created. There's a lot of information there today, so I know I'm going to be going back in and taking it piece by piece and working through that YouTube video to really take everything on board that's being discussed today. You mentioned you put up your email address and mentioned connecting with people there. Is there an opportunity for people to potentially collaborate with your students as well? Sure.
Yeah. I think my students are, because currently we're in AI-focused option studio. The students are very interested in like chatting with practitioners to see how from their research because they also want to get some like realistic feedbacks to improve their studio work. Yeah. Thank you if you're interested. I'm also happy to connect you with my students or help if you are interested in helping them developing their project.
Fantastic. And I guess I have a question initially before we go to there's some technical questions in here, and there's a really good question about the kind of legal aspects relating to this. Um, but some people have likened AI in our profession of architecture as being like when they first introduced CAD to our profession. It's, you have to get on board with it. Those that didn't got left behind. Um, do you agree with that? And yeah, how scared should we be? Like, how different do you think our profession will be in 5 years or 10 years?
Yeah, I totally think like what is because in 1980s CAD has like great impact in our domain. I think on one side we can treat AI as well, AI I feel AI is more generic. Like it's like the first quote I said is like electricity. So it can act as a CAD, or it can also act as an advanced version of Photoshop, right? So I think it will definitely change the efficiency of our work. But I truly think that the scary part is if we think about CAD, it's more about like automation or digitization, but it's not about like the design aspect. But AI kind of we are now fear about AI because AI is kind of we are fear that it will replace the creativity of the designers. So I think the very important thing when we play with AI is that, or actually when we develop this kind of AI related tools, is that we think of our designers' work. We have like 20% of the time doing the creative, like interesting work, but 80% are like boring part of the work, like figuring out the arrows, how to make the model clean. But I would say we when we use AI, we want to protect the 20% creative part, that we want AI only to assist us on that part. But on the automation part, that is actually the truly powerful one. That automation part, it can make the learning curve of all these digital tools super easy to learn, very accessible to everyone. So actually, I think the 80% boring part is the most powerful that we should focus on, not just on the visual style part.
Fantastic, thank you. There's a great question here by Emily that she asks, can you speak to disclosure in AI tool usage in our profession? Since drawings become contract documents, is there any discussion with how photorealistic a render should be in terms of in legal terms? Yeah, she goes on to talk about pre-digital drawings and it's not how it's not exactly the project how basically. I think this question is really about legal ramifications of generating design or using potentially other people's work through AI.
Yeah. So there's no formal rules about, like, especially for the image generation part for now. So from what I know, there's no like legal rules about the AI generated images, but many firms are concerned about the copyright issues. So that's why a lot of firms prefer, instead of using these open or commercial online tools, they prefer to establish the AI model locally. So there are some open source tools like the Stable Diffusion I mentioned. That's why a lot of firms they are fine-tuning their own model with their own data set to avoid the copyright issue. But yeah, I think that is the ethical part of the copyright, the legal issues of the image part is yeah, that's true. It's a big concern in the practice. It's less a concern in a tool using part, because the I would say the tool using part is less depending on the data that feeding it. Is more like connecting um, uh, like it's kind of integration the language instruction as an interface into the existing digital tools. I would worry less about that part.
Fantastic. I love the part when you talked about creating almost an AI visualization brand identity
Yeah.
by programming these software. And I think if you're using it as a tool like that, then obviously you're effectively using it to design, which is fantastic. Just going back to the software, you said at the end there that you gave the example of Nano Banana being a great place to start. If we're just for an architect just starting out in this, maybe they've just tried out ChatGPT and then, what's the next step? Would Nano Banana be next step? Like, what's an easy kind of, break into this whole AI field? What would you recommend?
Yes, I think the technical for the technical aspect, definitely the image generation tools, the current most powerful is Nano Banana, but there will be new ones. So the suggestion is you can start playing with it, but stay tuned with the AI news, with the demos. You can like every 1 month or 2 months, you can just search on the internet, search on YouTube to see if there's more advanced models. I personally I like looking at the demo videos just on YouTube and see what are the potentials. Then if I identify the potentials, I will just try the new tools because the current tool will definitely be the worst tool comparing to future tools. So the AI tools are evolving too fast, but the other aspect I would suggest to maybe keep updated, but it was trying is the MCP related tool. It's like, or actually integration of the language model into the digital modeling tools. Maybe it's not because MCP is like a technical word of how it's realized. Many tools are using MCP, but maybe the name of the software has a different name. But it's happening in all the digital tools. So that area basically using the language instruction to use the digital tools. That area I think is what will rapidly changing in the next 1 or 2 years.
Fantastic. A couple of technical questions here. Does NCP and Revit plus Revit work with Revit LT?
Actually, I'm not sure.
Okay.
Sorry, I'm not sure. You can search for that. I'm not like a heavy Revit user.
Yeah, fair enough. Actually, this was one I was interested in as well. Your students were what AI app or platform were they using to create those apps? Because that's something.
Nano Banana.
Oh, that's not a banana as well. Okay,
Yeah.
that's it. Um, yeah, thank you so much. I think we're coming up to the hour here. There's a couple of questions in here about is AI art? When it generates something, is that considered art? I mean, we could speak all day about these kind of getting into some pretty tricky areas there, but yeah, that's maybe a conversation for another day. But thank you very much to you, Sheldon, and it's been really fantastic intro to this massive subject. And thank you everyone who's joined us today. I hope it's been helpful, and hopefully we see you all again soon. Thank you. Take care.
Thank you.